Hello students and welcome to my math class. Today our chapter is factors and multiples. So let's start. Now comes prime and composite numbers. Now what are these? I have two friends, that is Jessica and Joseph. They are making cubes and cuboid using blocks. Jessica could only make two cuboidal shapes using 5 blocks. That is 5, 1 and 1, 5. That is because the number 5 only has two factors, 1 and 5 itself. Okay? Therefore, numbers more than 1 that have only two factors is called or are called prime numbers. So here we learned what are prime numbers. So what are prime numbers? For any number, for example 5 in this case, where it only has two factors, that is 1, the common factor for all of them, and 5, there's a number itself. Okay? Only two factors, these are 1, that is common factor, and 5, that is the number itself, is called a prime number. It's not more than that. Tell me another smallest prime number, that is 2. Yes. For 2 also, as per you know, it only has 1 and 2. That is, it only has two factors, 1, common factor, and 2, the number itself. Okay. We have here Joseph, our friend, is trying to make the shape of using 4 blocks. He could make 3 shapes. Now what are these? 4, 1, 1, 4 and 2, 2. Okay. Now that is because he has 4, which means it has 3 factors, 1, 2 and 4. So numbers more than 1 that have more than 2 factors are called composite numbers. Yes, C-O-M-P-O-S-I-T, composite numbers. So what are composite numbers? Composite numbers are any those numbers which has more than 2 factors. Like here we have number 4, for example. It has 1, the common factor, and 4, the number itself, and also 2, another factor. Let me take 6 for example. 6 factors are 1, 2, and what else? 3 and 6. Now here we have 4 factors. 1 is a common factor, 6 the number itself, and 2 and 3 are the other 2 extra factors. So thus I can say 4 and 6 are composite numbers. Okay, very clear to you? Yes. But keep in mind that the number 1 only has one factor. Yes, it had only one factor, that is 1 itself. So it's neither composite nor prime. Okay. So you have learned in this whole page 3 important things. The prime numbers are those numbers which have only 2 factors, that is 1 and number itself. Composite numbers are the numbers which has more than 2 factors, that is 1 and number itself, and also some other things as well. Okay. And 1, the number 1 has only one factor, thus it is neither prime nor composite. Very clear to you? You know what are prime numbers now? You know what a composite number, and you also know what is 1 that is neither prime nor composite. Wonderful. Let's move on now. Let's talk about application of this concept to help us find out the prime numbers between 1 and 100. We have learned about factors, multiples, common factors, common multiples, prime and composite number, and also about the rules of divisibility. Applying all this concept, let's talk about how to find out the prime numbers between 1 and 100. Okay. There's a simple method of locating prime numbers from 1 to 100. Let's see what is it. Let me take a huge table having number from 1 to 100, as you can see here. Let's talk about how I can find out prime numbers from here. The first thing you know is that the 1 is neither prime nor composite. Yes, you know that. So I'm going to cross 1 as it is neither prime nor composite. Number 2, I'm going to leave 2 as it is a prime number, but cross out all the multiples of 2. That is 4, 6, 8, 10, 12, 14, 16, 18, 20, and goes on, So here what I'm doing is simply keeping the 2 as if it is prime number, and all the multiples of 2 I'm crossing them out because those are composite numbers, and my aim is to find out the prime numbers. Yes? Yeah. As you can see here clearly, I'm crossing out all those numbers which has the last digit as 0, 2, 4, 6 and 8. That is using and applying the concept of divisibility of 2. So all the rules have been applied so far to help us do this activity. It's a very interesting activity. You can do it at home with your friends and find out prime numbers from 1 to 100. And check it out. Whoever finds it first is the winner. Yes? Okay. Let's see number 3 now. As per you, 3 is a prime number as well because it only has 2 factors, 1 and 3 itself. So let's cross out all the multiples of 3, leaving 3 aside. So first is 6. As you can see, 6 is already crossed out, so I want to focus on that. Next is 9. Then it comes to 12, it's already done, 15. Then it goes on, So cross out all the multiples of 3 as well. And we also have to cross out over here 27 as well. Okay, that's forgotten. 27 as well. Next comes 5. So leave 5. 5 is a prime number, yes. And cross all the multiples of 5, that is ending with 0 and 5 as a last digit. Then next, leave 7 but cross out all the its multiples, okay. These are like 14 and goes on. Okay. Now, what you have got here is a list of prime numbers up to 100. We have in total 25 of them, okay. So if you don't know by now, there are 25 prime numbers from 1 to 100. Let's see what this we have got so far. We have got 2, we have got 3, we have got 5, 7, correct? Yes. 11, 13, 17, then we have over here 19, 23, 29, 31, then 37, then 41, then 43, 47, 53, then we have 59, 61, 67, 71, 73, 79, 83, 89, and finally 97. As you can see in this given table, the smallest prime factor is 2 and the biggest, I should say, having the highest value is 97. So in total, we have 25 prime factors or prime numbers between 1 and 100, and very easy, yes? What do you mean by prime factorization? Let's see. All the composite numbers can be broken down into their factors. Let's see. We have a composite number, let's say 20 for example. I can split this number as 2 into 10, yes, I can do that. I can further write this as 2 into 5. And as you can see at this stage, when I have all the green numbers, it means that I have reached the factors. I can no longer go further than this. So that is a prime number, see, as you can see here. So let's take 20 again, but let's do it as 4 into 5, okay? And do it further as 2 into 2 and into 5. So as you can see, in either way, whatever we do, we're going to get at the end the same prime numbers. So as you can see in this given example, whichever way we start the division of the factors of the composite number, we end up getting the same prime numbers of prime factors at the end as a result. Thus, you can say now when the factors are all prime, it is called the prime factorization of the number. Very simple? Yes. So here we have the prime factorization of 20 are 2 into 2 into 5. Yes? And all these are prime numbers and the prime factors, and thus they are called prime factorization. Let's see some more questions. So we're going to solve few questions now using the prime factorization method. First number we have is 64. 64. Now step number 1 is to start with the smallest prime factor of 64, and that is 2, of course. So 2 into 32 is equal to 64. Again, branch down. So let's see how do you do this now. Step number 2. Next, find the smallest prime factor of 32, and that is 2 again. Yes, we're going to do that 2 into 16. And as per you know here, if you look at here carefully, we have 2 into 32 is equal to 64, and 2 into 16 is equal to 32. So this 2 which you have got is from here. Yes, remember that point, how we are branching it out. And third step is to continue to find the smallest prime factor at every step. So our goal is to find out all the prime factors of a given number, starting from the smallest prime factor and going on further until we get all our answers as prime factors. Let's move on. Let's go on doing it. You're going to get it like this way. That is 2 into 2 into 2 into 8. Further you can do. You're going to get here, as you can see here, very simple. 2 into 2 into 2 into 2 into 4. And lastly, we have 2 into 2 into 2 into 2 into 2 into 2 into. We have all the answers as such. As you can see, this last step is our all the prime factors of 64. Now look here carefully. You have got 2 into 8 from 16, 2 into 4 from 8, and 2 into 2 from 4. Now this number which you have got is the same thing here. This 2 is from this one, this 2 is from here. So as you go on further, you kind of write down the same thing. So remember that how many prime factor you have used, okay? As you can see, this is the same number over here, the same thing, and I've got the answer. Very simple. Now if you want, you can always check the answer here. We have 2 into 2 is equal to 4. 4 2 is 8. and 8 to the 16, 16 to the 32, and 32 to the 64. And I got the answer. Very simple, yes? Okay. So stop when the last row has only prime numbers, okay? Second question, to find the prime factors of 56 using prime factorization method. 56 number we have here. We're going to get 2 into 28, 2 into 2 into 14, 2 into 2 into 2 into 7. So this one, as you can see, the last step, here we have all the prime factors and here we stop, okay? Therefore, the prime factorization of 56 is equal to 2 into 2 into 2 into 7. Wonderful. What we have learned today? Today we have learned about the rules of divisibility by 2, by 5, by 10, by 3 and 9. Then we have learned about prime and composite numbers, and also we have learned about how 1 is neither prime nor composite, and thus you're able to find the 25. Remember, 25 prime numbers between 1 and 100, yes? And lastly, we have learned about prime factorization. That is when you get all the factors in terms of prime. So either way you do it, any way you do it, at the end, you're going to get all the answers prime factors, and then when you stop the process, okay? And we also revise about factors, multiples, common factors and common multiples. With this, we come to the end of today's lesson, and today I'm so proud of you. You have learned so much. Now I can truly say you are a math genius. If you have found this video helpful, and if you want more such math videos which you can learn at home, then please do subscribe to my channel for more such content in the future. And if you found this video really helpful, then please do share it to your friends so even they can learn math at home. Till then, keep learning and thank you.